So in this question, we have a rocket that was originally traveling at 6,600 meters per second. And then in an explosion, it separated into two fragments. And each section, let's just assume they're traveling in the same way, and they have a relative velocity of 2,800 meters per second. And they have equal masses, so that if the original mass is m, they would both be half of m. Let us first try to write down the conservation of momentum. So let's call this v, and this call this a, call this b. So we have va and vb. So before the explosion, we have mv. After the explosion, we have ma, which is just half of m, times va, plus mb, which is also half of m, times vb. So we can cancel m here, and this gives us v equals 1/2 va plus vb. And since this is v relative, this is v. We already know what v is, but we are trying to find both va and vb. And to do that, we first need to cancel one term. Let's use this relative velocity to cancel vb. So vb equals to va minus v relative. If we plug that into this equation, we have v equals half of 2va minus v relative. And from that, we can find va. va equals v plus half of v relative. So that is 6,600 meters per second plus 1/2, that is 40 meters per second. And that is 8,000 meters per second. And what about vb? vb equals va minus v relative equals 8,000 meters per second minus 2,800 meters per second, which is equal to 5,200 meters per second. So that is the velocity of VA and of section A and section B. And both are positive, meaning we did just happen to assume the right direction from the very beginning. So that is part A. So you can see, like, we don't really need to know the mass of the rocket for part A, but we do need to know that for part B. Part B asks us what is the change in kinetic energy. And so previously, we have kinetic energy initially equals half of mv squared. Afterwards, we have half of mva squared, mava squared, plus half of mbvb squared, which is, since ma and mv are just half of m, is 1/4 m times va squared plus vb squared. So then we're just trying to find the change in kinetic energy, which is ke final minus ke initial. So that is kilograms. We have 8,000 meter per square, meter per second, but square, plus 5,200 meter per second, also square. That is final kinetic energy, but minus the initial kinetic energy, which is half of m v squared. So that gives us a total of 7.11 times 10 to the 8th joule So we had a huge increase in kinetic energy from this explosion.